So we're going to go ahead and get started today. We're just going to go over the final review. Remember, your finals will be either tomorrow or Thursday, depending on when you schedule them with either your coach or your CCR. Remember, on your final, you get a calculator, a pencil. All of your work must be shown on your papers. You should also get, if I can find it, the reference sheet. So your reference sheet looks like this. There are parts of it that you will not use or don't need to know for your final, but this is the only reference sheet or notes per se that you get to use, and it'll be provided with your exam. So like the compound interest formula is on here and things like that. Oops. Lost my, here it is. All right, so question number 1, we're going to solve the equation. In order to solve this equation, we need to find the common denominator. To find the common denominator, we first of all want to start off by factoring this right here. So if we factor that, we're going to use the asterisk. Two numbers that multiply to give us -6 and add to give us 5, going to be -1 and 6. So that's going to give us factors here, m-1 times m plus 6. Conveniently, those are the denominators of the other two fractions. So my least common denominator is the m-1 times m plus 6. So we're going to go all the way across and multiply every single term by the common denominator. When we do that, we're going to be able to cancel something out of every fraction that will actually eliminate all of the fractions in our equation. So for this first problem, the m plus 6 is going to cancel with the m plus 6. That's going to leave us with 4 times m minus 1. For our second fraction, the m minus 1s are going to cancel, and that's going to leave us with plus 1 times m plus 6. Bring our equal sign down. The m minus 1s will cancel, the m plus 6s will cancel. And we're left with 3m plus 6. Now we need to go ahead and simplify to get rid of our parentheses. So we're going to distribute. So 4m minus 4 plus m plus 6 equals 3m plus 6. And then we just want to take this equation and solve for m, combine the like terms next. So 5m plus 2 equals 3m plus 6. Subtract 3m from both sides. That's going to give us 2m plus 2 equals 6. Subtract 2 from both sides, 2m equals 4. Divide both sides by 2, and m equals 2. Make sure on your final exam that you are going through and circling your final answers, especially on the questions that aren't multiple choice. So about half of the questions are multiple choice. There's 25 questions. First 15 of them are multiple choice. Question number 2, determine whether or not the function f of x equals x squared minus 4x is 1-to-1. So in this case, in Algebra 2, hopefully you learned what 1-to-1s and functions were, because this is the one question on the final that we didn't do something very specific that relates to it. So if we think about the problem we were given, the parent function here is x squared. When we graph anything with x squared in it, it's going to create a parabola. So just looking at this, I know automatically that this has to be a parabola. And anytime you have a parabola, for it to be 1-to-1, it must pass the horizontal and the vertical line test. So if I draw in vertical lines here, I can draw in as many as I want, and I'm only going to get it to cross through my graph one time per line. However, if I would draw in this line, oh, that's not very horizontal, but if I draw in this horizontal line, it would cross my parabola 2 times. So anytime your parent function is x squared, this is not 1-to-1. The reasoning behind that would be that it does not pass the horizontal line test. The question similar to this is going to be multiple choice. It's a yes or no question on your final. If your parent function is x squared, it's not going to pass that horizontal line test. Question number 3, solve the compound inequality. We're going to write our solution using interval notation and graph it on a number line. So first thing we're going to do is split this into 2 problems. We're going to have this problem here, and we're going to have this problem here. So remember that middle section does not get split, it gets used twice. So -7 is less than -3x plus 5. And our second problem is going to be -3x plus 5 is less than or equal to 5. We're going to solve both of these for x, remembering that if we either multiply or divide by a negative number, we must flip our inequality sign. So we're going to subtract 5. -12 is less than -3x. Divide by -3. We divided by a negative, so we're going to flip our sign. So we have 4 is greater than x. We always want x on the left-hand side, so x is less than 4, the first part of our answer. For the second piece, we're going to again solve for x. So we're going to subtract 5 from both sides. So -3x is less than or equal to 0. Divide by -3. X is greater than or equal to, because we have to flip our sign, 0. And again, since we divided by that negative, we had to flip our sign. So now when we go to our number line, we need values that are less than 4, but greater than or equal to 0. So I need a parenthesis at 4. My arrow's got to go to the left, but I also need a bracket at 0 with an arrow headed to the right. So these are going to overlap here in the middle. So I'm going to bring this down here, parenthesis here, and then our shading would be in the middle. And when we write that in interval notation, remember it's just bracket, parenthesis, and then the 2 numbers here in the middle, 0 to 4. So these bits of information right here are going to be your final answers. And this question on your final is multiple choice, so you're just going to have to find the correct graph. Make sure that they use the brackets and the parentheses appropriately. So quick review, anytime you have less than or greater than, that's when you use parentheses. When you have less than equal to, greater than or equal to, that's when you use the brackets. So here we have one of each. Question number 4, we have a ball thrown downward from a window in a tall building. Its time, or its position at time t in seconds is given by this equation where s is in feet. How long to the nearest 10th? Important information there, you have to round it appropriately. Will it take the ball to fall to 92 feet? So first thing we need to do is plug in 92 to the appropriate spot. So t represents time. S represents the height in feet, so we want to plug that 92 in here for S. Just like that. That's step number 1. Step number 2, we want to get 0 on one side, so we're going to subtract 92. So 0 equals 16t squared plus 32t minus 92. When I look at this, if I would try to factor it, I have some awfully large numbers, so I want to see if I can reduce. So we're going to find the largest number we can divide all 3 terms by. So we can divide all the terms on the right-hand side by 4 to reduce them, but if we're going to do it to the right side, we must also do it to the left side. So we're going to reduce by dividing everything by 4. Again, we got to keep it equal, so we're dividing both sides by 4. So 0 divided by 4 is 0. 16 divided by 4 is 4. The t squared comes down, plus 8t minus 23. Now we could try to factor this using our asterisk, but unfortunately it does not factor. So we're gonna have to use the quadratic formula. A, B, and C. Quadratic formula is given to you on your reference sheet, so you don't have to have it memorized. So x equals negative b, so negative 8 plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. When I have my students here in Muncie do this, we always type this part into our calculators. So we're going to take 8 squared minus 4 times negative 23. So now we have negative 8 plus or minus the square root of 432, all divided by 8. We can go ahead and figure out what these equal. If we use our calculators appropriately, we put this in parentheses, we can actually type in the whole thing. So negative 8, I'm going to do plus first, the square root of 432. I'm going to close my parenthesis, and then I'm going to divide that by 8. That's going to give me 1.59807621. We're rounding to the nearest tenth, so we just need 1 decimal place, so 1.6. Then we're going to repeat this process because we have that minus sign there in the middle. We're going to take -8 minus the square root of 432 divided by 8. Again, making sure to use those parentheses. And here we are getting -3.59807. So another rounding to -3.6. But remember, these represent T. I guess I wrote X up here, but T in context of the problem. T represents time, and we always talk about time being positive. We never talk about time in a negative manner. So the -3.6 is extraneous. Question number 5 is similar to what we did a couple days ago. This is our piecewise graph. So we have 2 options here. We need to make 2 T charts, one for the top and one for the bottom. So if I look at the top constraint, X is less than -1. That's an arrow going to the left with an open circle. We're going to start at -1. And if I think of numbers to the left of -1, you could do -2, -3, so on and so forth. I'm going to use -5 and -10 just so I get a wide range on my graph. Then we're going to plug those numbers in right here to X. So -1 plus 4 gives us 3. -5 plus 4 gives us -1. And -10 plus 4 gives us -6. So those are going to be 3 points. We could do more points, but we don't have to. So this is going to give us a pretty good, we have our starting value, -1, 3, open circle there, -5, -1, and -10, -6. So there's the first piece to my graph. I'm going to repeat the process for the second piece. Second piece, we have X is greater than or equal to -1. So our arrow is going to go to the right, and we're going to have a closed circle at -1. And again, we're going to pick numbers to the right of -1. So I'm just going to stick with the same pattern, use 5 and 10. You could do more X values if you wanted. So when I plug these in, I want -1 times the X value that we have. So -1 times -1 is +1. -1 times 5 is -5. And -1 times 10 is -10. So here are my 3 points I'm going to graph. -1, 1, again, has a solid circle because it's equal to 5, -5, and 10, -10. So that right there is my final graph. Question number 6. I don't know why this 38's in here, ignore it. An initial investment of $480 is appreciated for 2 years in an account that earns 17% interest compounded quarterly. Find the amount of money in the account at the end of the period. So this is our compound interest formula. Again, that formula is going to be given to you on your reference sheets on the top right-hand corner on the back. I did post the reference sheets on Google Classroom. So if you want to look over that before your final, please do. Find all the formulas you're going to want to use. So our formula here, A equals the principal, parenthesis 1 plus the rate divided by the number of times interest is compounded. to the NT power. Again, N is the number of times your interest is compounded. T is our time. Majority of the instances is measured in years. So to find the amount in the account, we're going to start with A equals the principal. The original amount is $480. 1 plus the interest rate is 17%. Converted to a decimal is 0.17. Make sure you're taking that 17% and converting it to a decimal. In the number of times that your interest is compounded per year, in this case, they tell us quarterly. Quarterly means 4 times per year. Then our exponent, we need the time times 4 because of the quarterly. So we're going to take 2 times 4. You want to go ahead and write 8 up there. That's just as fine. Then you're going to type this in your calculator just as it's written. So 400 parenthesis 1 plus 0.17 divided by 4. Close your parenthesis, caret key parenthesis 4 times 2. Or again, you could put that 8 up there. So the amount we're getting is $669.65. Be careful on your exam. It's going to be multiple choice, and there might be answers similar, but not exact. So be cautious when you go to do that circling. Question number 7, graph a pair of functions. F of x equals the absolute value of x, and g of x equals negative 0.5, the absolute value of x minus 2 on the same plane. Use a solid line for f of x and a dashed line for g of x. You are going to be given on your reference sheet the parent function, f of x equals the absolute value of x. So you don't have to worry about memorizing it, it's on there. This. So there's our parent function. Again, it's on your reference sheet, so you don't have to memorize it. And then looking at our new equation, I look at this and I automatically see that the minus 2 is inside with the absolute, or with the x and the absolute value bars. So I know that's moving to the right 2. There's no up or down shifts. So I know this point right here is going to be moved right here. The negative out front tells me it's going to reflect over the x-axis. So I just need to take some points and I need to plug them in to find their y values. So first point I would start out with would be 2. And then just keep plugging in numbers, 2, 4, 6, 8. And we're going to plug them in right here for x. So negative 0.5 times the absolute value of 2 minus 2. And then we're going to use our order of operations to find these numbers. So 2 minus 2 gives us 0. 0 times negative 0.5 is just 0. So we have that point already on our graph because we knew that it was moving to the right. For 4, we're going to use 4 minus 2, which is 2. The absolute value of 2 is positive 2 times negative 0.5 is negative 1. So that's going to give us the ordered pair 4, negative 1. Then we're going to plug in 6. 6 minus 2 is 4. The absolute value of 4 is 4. 4 times negative 0.5 is negative 2. So I'm going to graph the order pair 6, negative 2. 8 minus 2 is 6. 6 times negative 0.5 is negative 3. So now I have half of my graph. Oops, I was supposed to draw that dotted. Just like that. Then we're going to reflect them. Remember, we're reflecting over the center, which is now here. So this point is 2 to the right. I'm going to go 2 to the left, and I'm going to put a point here. I'm going to do the same thing to get the rest of the points. And I'm just going to draw in my dot. Again, this question will be multiple choice on your final. So you'll just have to find the correct graph. Again, I highly suggest that you take the time to make your table in order to check your points. Question number 8, find the domain and range of this logarithmic function. Make sure to write your answer using interval notation. Remember, for the domain of a logarithm, whatever's right here in parentheses must be greater than 0. So we're going to take this, set it greater than 0. We're going to subtract 3 from both sides. So negative x is greater than negative 3. Got to get rid of that negative that's in front of the x. So divide by negative 1. That's going to give us x is less than 3. It's less than because we have to flip our sign. So we divide it by that negative, so our sign flips there. So when I write my domain, I need any x value that's smaller than 3. So negative infinity to positive 3. Our range is always the same thing. It's all real numbers, which in interval notation is negative infinity to positive infinity. Also be warned that on these multiple choice, they're going to switch them. They're going to give you the domain is the range is the domain, and they might be correct just in the wrong spots. So be mindful of that as well. So the range is the one that's always all real numbers, negative infinity to positive infinity. Question 9, we're rewriting this expression using sums and or differences of multiple logs. So we're expanding. When we expand here, we're going to have 2 different operations. So we have multiplication and we have division. So we're going to separate the tops using addition, and then the bottom will get separated using subtraction. So we're going to have log base 3 of x squared plus log base 3 of the 4th root of y minus log base 3 of 9. So now to keep expanding, we need to take this exponent, bring it down out front. So 2 log base 3 of x, that's finished. For the middle one here, remember that this 4th root is the same thing as y to the 1/4 power. That 1/4 gets brought down out front. So 1/4 log base 3 of y. minus, for this part here, since there are no variables, we want to take our calculators and we want to use the change base. Formula and take log 9 divided by log 3 in our calculators to figure out that log 9 divided by log 3 equals 2. So we're going to simplify that to 2. So this right here is our final answer. So 2 log base 3 of x plus 1/4 log base 3 of y minus 2. Question 10, a company's weekly cost in dollars is given by C of x equals 5x squared minus 200x plus 1,000, where x is the number of items produced during a week. For what number of items is the cost minimized? So here we want to find the minimum, which in this case is going to be the x coordinate of your vertex. Find the x coordinate of our vertex, we're going to take x equals negative b divided by 2a. This is given to you on your reference sheet in the bottom right-hand corner on the back page, I believe. So here we have a, b, and c. So we're going to take negative b, which means negative 200, negative 200, a double negative there, divided by 2 times a, which is 5, and then we just want to simplify this. So this is going to be positive 200 divided by 10, while positive 200 divided by 10 is 20 items. And that's your final answer. Question 11, we're going to sketch the graph of f of x equals 3 to the x power plus 2. Remember, for exponential problems, we always use -2, -1, 0, 1, and 2 as our x values. And then we're just using our calculators to compute these values. So we're going to take 3 caret key -2 plus 2. You might have to hit your equal sign here in the middle, depending on what calculator you're using, or put parentheses around this. Oh. So you should get a value on this of 2.1 repeating, 2.3 repeating, 3, 5, 11. So then we're going to graph those -2, 2.1 repeating, -1, 2.3 repeating, 0, 3, 1, 5, and 2, 11. We're going to estimate up there. So that right there would be the sketch of my graph. Question number 12, in January of 1983, Anna starts a new job and makes an annual salary of $38,000. By January of 1986, her salary is increased to $46,300. What is the average rate of change of her salary between January 1983 and January of 1986? So what we need to do here is find the slope, essentially our rate of change, y2 minus y1 over x2 minus x1. I think we did this the first day of class, or the second day of class. So we're going to take her new salary minus her old salary. So $46,300 minus our old salary, $38,000, divided by the current year, 1986, minus when she started, 1983. You're finding the change in her income divided by the change in time. So some students will do this in their heads without, or do it in their calculators without even thinking about it. So her salary has gone up by $8,300 and 3 years has passed. So some students think of it that way. Anna's earning $8,000 more and it's taken 3 years for her to gain that. So now we need to simplify this and figure out how much extra she's been earning on average per year. So her salary has gone up $2,766.67 per year. And remember, we round that to the nearest penny. So that's 6.7. Question 13, we're given two functions and we're asked to find f minus g of 2. I highly suggest that you find f minus g first and then you plug in the 2. So if we take f minus g, we're going to start with f, 3 minus 2x minus g, which is negative 9x squared plus 4. So we just took f and put it in parentheses, minus g, put it in parentheses. So now we want to get rid of that minus sign by distributing it. It's going to change all the signs that follow in that set of parentheses. So positive 9x squared and negative 4 now. And now I'm just going to combine like terms. So I'm going to have 9x squared negative 2x or minus 2x, and then minus 1 when I combine these two here. Now that I have that, I want to take this 2 and I want to plug it in for x right there and right there. So I'm going to have 9 times 2 squared minus 2 times 2 minus 1. I'm just going to type that in my calculator the way that it's written. You could simplify it by hand, but since you're on a time limit, you're going to want to use your calculator to just type this all in at once. You get 31 as your answer. Question 14, find the remainder when 2x to the 4th minus x to the 3rd minus 7x squared minus 3x plus 10 is divided by x minus 2. So when we do these, remember that we want to make sure that every degree is accounted for. So if we start with x to the 4th, we want to make sure that our exponents go down by 1s. And we're not missing anything. If an exponent is missing, make sure you plug in a 0 where that exponent or where that term should be. So in this case, since I start with x to the 4th, I'm going to need 5 boxes across the top. Those coefficients go in these boxes. So when I look, I start with 2x to the 4th, negative 1x to the 3rd, negative 7x squared, negative 3x, and positive 10. All of my exponents decrease by 1. So 4, 3, 2, 1, and then no x's for that last term. Make sure on your final that you're accounting for every single exponent. Then we need to find the number that sits out here by itself by taking this instead of equal to 0. Well, if x minus 2 equals 0, you're going to add 2 to both sides to get x equals 2. So 2 is going to be our magic number standing out here. Then we're going to fill out our synthetic division, bring the first number down. We always multiply to get the middle. So the next thing we want is the middle. So we're going to multiply 2 times 2 to get 4. And we're going to add straight down. Negative 1 plus 4 is negative 3. Multiply again to get the new middle. 3 times 2 is 6. So it goes in the middle there. Negative 7 plus 6 is negative 1. Multiply again to get the middle. 2 times -1 is -2. Add straight down, -5. Multiply one more time to get the middle. 2 times -5 is -10. Add straight down to get 0. Our question asks us for the remainder. Remember, this last box is your remainder. So our remainder is 0. So find your remainder for this question. Make sure the last number, the bottom of your box, is your answer. Question 15. Here we're given the graph of a function. We need to determine the leading coefficient, the degree if it's even or odd, and then our end behaviors. So I always start off looking at the graph overall, seeing where my end points or my arrows are going in this case. So here my arrows are going opposite directions. That tells me the degree is automatically odd. Odd means your arrows are going opposite directions. One's going up, one's going down in this case. For our leading coefficient, we want to focus in on the right-hand side of our graph. If the right-hand side of our graph is going up, it's positive. If the arrow is going down, it's negative. So in this case, our arrow on the right-hand side is going up, so the leading coefficient has to be positive. For part C, we need to determine our end behavior. So this is asking us, hey, what are the arrows doing on the left and the right-hand side? So this means, what is the arrow doing on the left-hand side? As x approaches -infinity, that's the left. My left arrow is going down. I have to decide which one of these two options here represents an arrow going down. Well, y approaches -infinity would be going down. For the other part, the arrow is heading to positive infinity, so that's the right-hand side. For the right-hand side over here, the arrow is going up. That means your y values are increasing or approaching positive infinity. Also, one thing to know, if you say that the degree is odd, you should have opposite answers here. One should be positive infinity, one should be negative infinity. So if the degree is odd, those should be opposites. If the degree is even, they should both be the same, either both negative infinities or both positive infinities. Question 16, find the inverse of the function. So to find the inverse of a function, we need to start off by taking the function notation out and replacing it with y. So we're going to take this out. We are going to replace it with y. Now that we've done that, we want to invert. For step 2, we're going to switch our x's and our y's. Just like that. So x became y, y became x. Step 3, we want to solve for y. In order to solve for y, it's stuck in this set of parentheses. So the first thing I need to do is isolate this whole set of parentheses. So I'm going to subtract 2 from both sides. So x minus 2 equals y minus 3 squared. In order to get rid of those parentheses, I need to get rid of the squared. The inverse, or the opposite of squaring something, is to take the square root. So we're going to take the square root of both sides. On this side, the squared and the square root cancel, leaving us with y minus 3. On the left-hand side, we're just gonna have x minus 2 underneath that square root. We can't do anything with it, so we're just gonna leave it as the square root of x minus 2. Then we need to get rid of the minus 3, so we're going to add 3 to both sides. Be mindful that the negative 2 is stuck underneath the square root, so it cannot come out. So we're going to have the square root of x minus 2. The plus 3 is going to hang out at the end, and that equals y. Last thing we need to do here is write this in inverse notation. F inverse of x equals, and then we're just copying all this down here. So the square root of x minus 2 plus 3. And this is my final answer. This is the first question on your final that's open-ended. Make sure you're showing all of your work on your paper. You cannot use scratch paper on your final. Question 17, we're going to simplify the expression. We want to make sure to write our answer in complex form or complex number. In standard form, it's got to be written in A plus BI form. So for these, we want to start off by multiplying by the conjugate. The conjugate means we're going to look at the denominator, we're going to change the sign in the middle. We multiply the bottom by the conjugate, we multiply the top by the conjugate. So this actually creates 2 box problems. You're going to have a box problem for the numerator, and you're going to have a box problem for the denominator. So I'm going to create a box. I plus 5, 3 plus 2i. And I'm going to have another box. For the denominator. Then we're just going to fill out both of our boxes by multiplying. So 3 times I is 3i, 3 times 5 is 15. I times 2i is 2i squared. Remember, I squared gets replaced with -1. So this box actually turns into -2. My bottom right box, 5 times 2i is 10i. So for my numerator, I'm going to have 15 minus 2, which is 13. And then 3i plus 10i, 13i. Then remember, we're going to divide both of these terms by the denominator. To find my denominator, we're going to take 3 times 3 to get 9. -2i times 3 to get -6i. 3 times 2i to get +6i. -2i times +2i to get -4i squared. I squared gets replaced with -1. -1 times -4 is +4. So when I go to write my denominators here, I'm going to take 9 plus 4 to get 13. My -6i and my +6i are going to cancel. So here my denominator is just 13. Now I need to look at each one of these fractions individually to see if I can reduce. So my answer, 13 divided by 13 is 1, plus 13i divided by 13 is 1i, or just I. So this right here is my final answer. May or may not reduce on your final, but just be warned, it could reduce, and if it does reduce, you need to reduce it. Question 18, we're solving the absolute value equation. In order to solve an absolute value equation, you must first of all get the absolute value bars on one side by themselves. So we need to isolate the absolute value of x plus 3. In order to do that, we're going to start off by subtracting 10 from both sides. So 2 minus the absolute value of x plus 3 equals negative 10. Here is where students tend to mess up this problem. So we have the 2 and then we have the minus. That minus is like a little negative 1 sitting out front here. We cannot just subtract or add 2 to get rid of both of those. We've got to do them separately in 2 steps. So we're going to subtract 2 to get rid of this. We're still going to have that little negative 1 sitting there. And now we've got negative 12 on the right-hand side. We're not going to distribute that negative. We're going to get rid of it by dividing both sides by negative 1. So that's going to cancel out. We're going to have the absolute value of x plus 3 equals 12. We now have our absolute value bars isolated. Once we get here, we're going to break this apart into 2 pieces. Remember, we're going to write it one time with a positive 12. We're going to write it one time with a negative 12. So we're going to have x plus 3 equals 12, and then we're going to have x plus 3 equals negative 12. Remember, whatever's inside our absolute value bars before we take the absolute value of it could be either positive or negative. Only when we take the absolute value of it does it become positive. And now we're going to solve both of these for x. So first one here on the left, I'm going to subtract 3 from both sides. X equals 9. I'm going to subtract 3 from the question on the right. That's going to give us x equals negative 15. 2 answers there. Question 19, we're going to solve this equation. Keep in mind they've told us to check our solutions in the original equation. I promise they're not telling you that for no reason. So in order to solve this one here, we first of all need to isolate the square root. So we want to get this by itself. I'm going to get rid of that 4. So subtract 4 from both sides. So the square root of 11 minus 2x equals x minus 4. Now that we have that square root isolated, we can go ahead and square both sides. When we square the square root over here, they're going to cancel each other out, leaving us with 11 minus 2x. On the right-hand side, however, we have a binomial being squared. So 2 terms being squared. We've talked about how this creates a box problem. So we're going to box x minus 4 times x minus 4. A lot of students want to just say that that's x squared plus 16. I promise it's not. You're missing the middle term. So we're going to have x times x, which is x squared. Negative 4 times x, which is negative 4x. X times negative 4, which is negative 4x, and then negative 4 times negative 4, which is positive 16. When I combine like terms here, I have x squared minus 8x plus 16. So that minus 8x there in the middle is what students a lot of times miss or leave out. When I look at this now, I have a quadratic. Since it's a quadratic, I want to move everything to one side. It's easiest to just move the 2 terms from the left to the right. So subtract 11 and add 2x. These are both going to cancel. So 0 equals x squared minus 6x plus 5. Again, since that's a quadratic, we're going to factor using the asterisk. 2 numbers that multiply to give us 5, but add to give us -6, -1, and -5. So our two factors here, x minus 1, x minus 5, order doesn't matter as long as you get both of those. The zero product property tells us, since we have two things being multiplied together and their product is 0, that one of them must equal 0. So x minus 1 equals 0, x minus 5 equals 0. It's going to give us x equals 1 and x equals 5. Like I said a few minutes ago, they didn't tell you to check your solutions in the original equation for no reason. So you've got to take both of these and plug them back in to the original. So if I take 1 and I plug it back into this right here, I would have the square root of 11 minus 2 times 1 plus 4 equals x, which is 1. Then I'm just going to simplify each side individually. I'm going to take 2 times 1, which is 2, 11 minus 2, which is 9. So I have the square root of 9 plus 4. Well, the square root of 9 is 3. 3 plus 4 definitely isn't going to equal 1. So right there, automatically, I see that this is going to be extraneous. I still have to check the 5, so I'm going to go back into the original, and I'm going to check 5. So 11 minus 2 times 5, square root, plus 4 equals x, which is 5. So I'm going to simplify 2 times 5 is 10. 11 minus 10 is 1. So the square root of 1 plus 4 equals 5. The square root of 1 is 1. 1 plus 4 is going to equal 5. So this answer is a solution. The other one is extraneous. You didn't do anything incorrect in the problem. It's just an extra answer that doesn't pan out when you check it. Next up, we're going to look at this function, identify the vertical, horizontal, and oblique asymptotes. Promise there are none that are oblique. For our vertical, I'm going to label VA, maybe. For our vertical, remember the denominator cannot equal 0, so we're going to take x squared plus 6x minus 27, set it equal to 0, and we're going to factor. We're going to factor this using the asterisk. We're looking for two numbers that multiply to give us -27, but add to give us 6. So in this case, we're going to select +9 and -3. So I'm going to have factors x plus 9, x minus 3 equals 0. Again, that 0 product property tells us that if we have two sets of parentheses, in this case being multiplied together and their product is 0, then one of them must equal 0. So x plus 9 equals 0, or x minus 3 equals 0, going to give us x equals -9, x equals +3. Those are both vertical asymptotes. Keep in mind, for full credit on this question, you must have x equals -9, x equals 3. You can't leave off the x equals because it's representing a line. So the x has to be there, or I have to count off a point. For our horizontals, we're going to compare the degrees, the highest degree of the numerator to the highest degree of the denominator. So in this case, the degrees are the same. So we're going to start with y equals because it's horizontal. And in this case, we're just going to make the fraction created out of the leading coefficient. So 3/1, which is just 3. So our horizontal is y equals 3. And like I said, there are no obliques. That happens when the numerator exceeds the degree of the denominator. It's not going to happen, I promise. Question 21, we are given a quadratic inequality. For our quadratic inequality, we need to, first of all, factor what's on the left-hand side. So it's already essentially set equal to 0. Remember, the inequality doesn't change anything until we get our x values. So we're going to factor x squared minus 10x plus 24. So we're going to have 24 in the top middle, 1 on the left and right, negative 10 in the bottom middle. Two numbers in the multiply to give us negative 10, but add to give us 24. That's going to be negative 6 and negative 4. So our two factors, x minus 6, x minus 4. We're going to send them both equal to 0. It's going to give us x equals 6 and x equals 4. If you remember from way back when we did this, it seems like forever ago. We're going to make a number line. The only two numbers we care about are 4 and 6. Make sure you put them in numerical order on your number line. I know we found 6 on the left, but 6 actually is larger than 4, so it has to go to the right on our number line. Now we need to check the 3 regions that are created. So we have this region, we have this region, and we have this region. So when we check these, we can pick any number we want. So when I check this region, I would check 0, because it's smaller than 4. So I would take 0 squared minus 10 times 0 plus 24 and see if that's greater than or equal to 0. Well, these are going to be zeros. 24 is greater than or equal to 0. So this first region is going to work. It's going to give us a true statement. Then we're going to check another number. In this case, I would say the most obvious would be to check 5. If I check 5, I would have 5 squared minus 10 times 5 plus 24, and I want to see if that's greater than or equal to 0. If I compute this, 5 squared is 25 minus 50 plus 24, that's going to actually give us negative 1 is greater than or equal to 0. That is not true. So this section is not part of my solution. For the region on the right, again, it doesn't matter what number you choose as long as it's larger than 6. You cannot use 6, so I'm just going to use 7. 7 squared minus 10 times 7 plus 24. Hopefully that's greater than or equal to 0. Just using my calculator to compute that gives me 3 is greater than or equal to 0, which is true. Oh, so now I have these 2 regions that are in yellow that are part of my answers, and I need to write that in integral notation. So for the region on the left, the arrow goes to negative infinity, and it stops when it gets to 4. Ask yourself, is 4 included? 4 is included because of this symbol right here. So it's going to take a breath. We're going to unite that with the second part of our answer. We're going to start at 6. 6 is included again. And that arrow heads to positive infinity there on the right. So this right here is our final answer. Question 22, find all the real and imaginary zeros for this polynomial function. We're going to start off by using synthetic division. So my leading or my highest degree here is x to the third, which means I'm going to have 4 boxes across the top. I have my coefficients 2, 1, -5, and +2. And then we're going to always try to factor out a -1 or a +1. I'm just going to start with +1, see if it factors out. Promise you on your test, either +1 or -1 will work here. So multiply to get the middle, 2 times 1 is 2. Add straight down to get 3. Multiply again to get the middle, 1 times 3 is 3. -5 plus 3 is -2. -2 times 1 is -2, and -2 plus 2 gives me 0. The remainder being 0 tells me that 1 is a 0 or a solution. So x equals 1 is part of my solution. We're going to take the remaining pieces here and we're going to write them as 2x squared plus 3x minus 2. Since the remainder is 0, we're leaving it off. Again, your bottom row always starts 1 degree less than your original because you factored out one of the x's. We're going to take this and we're going to factor it using the asterisk. So 2, 2, 3, and -4 in the top middle. Be careful. 2 numbers that multiply to give us -4, but add to give us 3. That's going to be 4 and -1. We're going to reduce the 2 and the 4 to be 1 and 2. So we now have factors x plus 2 and 2x minus 1. We're going to set both of these equal to 0 to get x equals -2 and x equals 1/2. Make sure you add those to your solution from earlier that you factored out, either that -1 or that +1. To get your final answer. So -2, 1, and 1/2. Question 23, we're going to solve this equation. Again, they tell us to check in our original equation. There's a reason why they're telling us that. So be mindful of that as well. In order to solve these, or this equation, we first of all must combine our logs. Since the symbol in the middle is addition, we're going to combine them using multiplication. So far we have this. I would draw myself a box out to the side to go in and multiply the x minus 3 times x plus 4. So that's going to give us x squared plus x minus 12 equals 3. Now we want to convert this to exponential form. So here's our base, here's our x, here's our y. We want b to the x power, so 2 to the third power equals y, which is x squared plus x minus 12. Now we have a quadratic. We need to get 0 on one side so that we can factor it. Well, first of all, we need to figure out what 2 to the third power is. That is not 6. That is 2 times 2 times 2, which is actually 8. So we're going to subtract 8 from both sides. So 0 equals x squared plus x minus 20. We're going to factor that using our asterisk. -4 times +5, so 0 equals x minus 4 times x plus 5, which means x equals 4, x equals -5 when I set them both equal to 0. So there's a lot of steps that I'm showing. You wouldn't have to write out every single step, but I need enough that I could give you partial credit when I grade it if something is wrong. So now we have two answers. Again, the instructions said to make sure you check in the original equation. Remember, with logarithms, you need to check that if you plug something back in, you do not get a negative in here in these parentheses. So the first answer we have is 4. If we plug 4 in here, we have 4 minus 3. That's going to give us 1. That's okay. If I plug 4 in here, 4 plus 4 gives us 8, and that's also good. So it looks like 4 is going to be good here. Then we're going to check -5. So if I go back here and I check -5, if I plug in -5 minus 3, that gives me -8. I'm not allowed to have a negative in those parentheses, so automatically -5 is getting marked off my list. I don't even need to check at this point the other logarithm. Last two, solve the following equation. Make sure to round your answer to the nearest 4 decimal places. So for this one, we're starting off with 4 times 5 to the 2x minus 1. You must, first of all, get rid of this 4. So that 4 is being multiplied by the 5, so we want to divide both sides by 4. That's going to give us 5 to the 2x minus 1 equals 2. At this point, we're stuck. So the x is stuck in the in the exponent. The only way to get it out is to change this to a logarithm. So this is b, this is our exponent, and this is our y. So we're going to change this to log base b, so log base 5 of y equals x, which is 2x minus 1. So we have log base 5 of 2. So far, that's okay. We're going to get x by itself by adding 1. So we're going to have log base 5 of 2 plus 1 equals 2x. Then we're going to divide both sides by 2 to get x by itself. The tricky thing about this problem is that you cannot type this portion in your calculator. You have to use the change of base formula. So the tricky part happens on this problem when you go to type this all into your calculator. So in your calculator, you're going to want to take log 2 divided by log 5. That's your change of base formula. Plus 1. I would hit equals and then divide that by 2. You could also hit equals before you add 1. Could use double sets of parentheses. There's a lot of ways you could type this in, but you've got to be very careful doing that. You should get an X value when you round to 0.7153. And again, you've got to keep 4 places after the decimal. All right, last one. We're given 2 functions, and then we need to find this composition. Notice this is an open circle here, so we've got to take g of x and plug it into f. So we're going to take this in parentheses, and we're going to plug it right here where this x was. So we're going to take this x out and replace it with those parentheses. So we're going to have 3 parentheses 2x minus 7. Those are parentheses, then this squared comes down, and then the plus 5 comes down. So now we need to, in order to simplify this, we need to compute this portion right here, the 2x minus 7 squared. Easiest way to do that is to draw yourself a box. You're going to take 2x minus 7 times 2x minus 7. So when I fill that, I'm going to have 4x squared, negative 14x, negative 14x, and positive 49. So combining like terms, 4x squared minus 28x plus 49. Don't forget to bring down the plus 5. In order to get rid of the parentheses, now we need to distribute the 3. So 3 times 4x squared is 12x squared. 3 times negative 28x is negative 84x. And 3 times 49 is 147. 3 doesn't get distributed to the plus 5. We're just going to bring it down again. Our last step here, we're going to combine like terms, the 147 and the positive 5 get added together. So 12x squared minus 84x plus 152. And that right there is our final answer.